I'm Anil Kumar. Welcome to my series on advanced functions. Here we are discussing a test paper of Unit 1. This is question number 15. Determine the function g times f if f of x equals to minus 1, 2, 0, 5, 1, 0 and 2, 1. So these are the 4 points on the function f of x. G of x is given to you as square root of x minus 1. You can always pause the video, answer this question, and then look into my suggestions. Well, let me first sketch this, and then we will discuss how to solve such questions, right? First thing to understand here is that when we write GF, it really means we are looking for a product of this, right? So that is like G times F, right? So outputs are going to be multiplied. Now that only happens on the common domain, right? Now let's try to sketch the function. Let's say, let me sketch g of x first. G of x is given to us as square root of x minus 1. So that means at 1, the value will be 0, right? So let's say this is 1 for us. Let me make some scale. 1, 2, 3, 4, 5. And here we have 1, 2, 3, 4, 5, 6. So if I substitute x equals to 1, I get 0 here. So that is 1 point. If I substitute 2, then I get square root of 1, which is 1. So 3, 4, and if I substitute 5, 1, 1, 2, 3, 4, 5. 5 minus 1 is 4, and the square root will be 2, right? So I get this function kind of like this. So I could draw this function as this. So that is our g of x. Now let's look into the function f of x. So I'll sketch these 4 points using this greening, minus 1, 2. So at minus 1, we have a value 2. At 0, the value is 5. So at 0, it is 1, 2, 3, 4, and 1, 5. At 1, it is 0. So at 1, it is 0. At 2, it is 1. At 2, it is 1, right? These are the values. Now clearly, you can see from here that these are the only 2 values which are in the same domain, right? So these are the only 2 points which can be multiplied, correct? So we could write g of f as equal to these 2 points. So when x is equal to, at this point, when x is equals to 1, the product 0 times 0 is basically 0. Right? The other point is when x is equals to 2, that is 1 times 1, right? So both get value of 1. So at 2, the answer is 1. Do you see that? So those are the solutions for this. The product of the function gf is basically these 2 points. Is that correct? Right? So that is how you could actually find the product of 2 functions. So I hope it is absolutely clear. So you can introduce more points and see how it changes. Okay. Now let's take up the last question, which is question number 16. The question here is, the graph of y equals to square root of x is reflected on the y-axis, is horizontally stretched by a factor of 2. Shift 3 units up and 1 unit left. Write the equation of the transform function. So we are given the function y equals to square root of x. The transformations here are, first, reflected on y-axis. So if you reflect this on y-axis, then what do you get? You get this function as minus square root of x, correct? Horizontally stretched by a factor of 2. Second is horizontally by a factor of 2. That means inside this, right? So it becomes square root of half x. That's what it means, right? Then we have shifted 3 units up and 1 unit left. So we have 3 units up and we have 1 unit left. So when I say 3 units up, then it becomes, the function becomes minus half x. Up means 3 units, we have to add 3 outside. And 1 unit left means the function becomes minus half x. Now, 1 unit left means you have to put it in brackets plus 1. And you have this function. Is that clear to you? Correct? So, we can write that the transformed function, write the equation of the transformed function, and so clearly the equation of the transformed function can be written as, we have just right there, f of x is basically equal to minus within square root half of x plus 1 plus 3. This portion is within the square, right? So this is negative, right? So let me rewrite. So it is minus square root of half of x plus 1 plus 3. Okay? So that is how you get your transform function. So I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.